Hey everyone, in this video we're going to go ahead and take a look at permissions and ownership. So we'll start by checking out our example directory here. And here we can see that we have the permissions here. First, we have the D that actually represents directory. If that's a file, it's actually just a dash. Then the next three represent the group of the file or folder. And then we have all other users on the system. So as far as our permissions go, the owner has read, write, and execute, are representing read. That allows us to read files and also read the contents of a directory. If you have write permissions within a directory, you can create subdirectories. You can also write to files and delete directories. Execute allows binaries and scripts to be run. And then here, we've gone over this before, but we'll discuss it later and demonstrate how this works. Is we have the owner of the folder, and then we have the group on the folder. And again, going back here, we can see the first three represent the owner, second three represent the group, and then the last three would be any other users on that system. So that's a quick overview of what each permission represents and the symbolic notation. There's also octal representation that shows permissions, and you can see that with a stat. And so right here, we actually have 4 different permission settings. First is for special permissions, and that's something we're going to cover in another video. And the next is going to be the owner's permissions, the group's permissions, and the all other user permissions. So the way this works is this actually is an octal that is represented in digits 0 to 8. And you have 4 for read, 2 for write, and 1 for execute. So you're going to see an accumulation of what a user's rights are. It's 0 for special because there are no special permissions set. And then in this case, for the owner has read, write, and execute, which adds up to 7. And then the group has read and execute, which will add up to 5. And then the same for all other users. So now let's clear this up. Now let's talk about UMask. UMask is actually going to be the setting that affects what permissions files and folders are created with. And so to demonstrate this, let's create a directory. And recall that I don't have write within this directory, so I can't actually create anything in here with my account. I'm not a member of the root group, only root should be a member of that group. And so I'm going to fall under all other users and no write. So I'm going to go ahead and use sudo. And we're going to go ahead and create a file too. I'm going to run a couple commands together here. All right, so by default, we see that we have 755 on our directory and 644 on our file. And this is because the UMask that is set on our system. So currently, this is what's set for our system. And the way that UMask is going to work is for directories. You can take 777 and subtract the UMask that you're going to have. We'll actually make it 0777. Include the special permissions bit in there. You can also include that on the UMask. Subtract. So that's going to leave us with 755 is how directories will be created. And UMask is something I could actually run this command and then I could pass an argument to it to actually change that for system-wide. It can also be controlled in the user's profile. That's something we'll get into in a later video, but for now, just know that there's a couple ways that you can change that. So the same with our files. And we'll just make sure we include that as well. Completeness. So then what we're going to see is 0644 when we create files. All right, let's clear this up. Just run what we have here. Earlier, I got denied when I tried to create a directory in here because I didn't have the appropriate permissions. To demonstrate changing permissions here. So first we'll demonstrate changing them with octomode. So we'll go ahead and change the permissions on my file. And the command for that, chmod, I'm going to have to do this as root with sudo because I don't have any access here. So we'll give it everyone read, write, and execute to my file 777. And as we can see here, owner, group, and all other users have read, write, and execute. Go ahead and set that back. 644. And now it's read, write, read, read. And we can also set it so only the owner or even only the group and the owner have access. So how we would set this for only the owner. And now only the owner has access to the file. Also, just to point out, we talked about UMask earlier. We can override the UMask by creating directories with certain permissions. So for example, with the -m flag, and then we can set that with the octal representation. Now we have a new directory that only the owner has permissions to access. We can also set permissions using the symbolic representation. So for example, we can add read for the group on my file. Group plus read file. And now group has read on my file. And we can also take permissions away. So from the owner, and that is represented with the U. Now execute has been removed from the owner. And we also have the option of adding multiple if we comma separate. So we can give the group read and execute. And we can also give all other users read. And now the group has read, write, and execute. And now the other users group has read access to the file. We can also use the A flag to pass all users to the command. So for example, let's set our permissions so that no one has permission. Let's go ahead and run all users plus read file. And now all users have read. All right, let's go ahead and change permissions on that. Let's read, write, execute for everyone. Screen here. And there's actually another way where we can use the symbolic permissions and we can set it exactly equal to something. So for example, if we chmod, this would be the user or the owner, read, write on my file. And we're actually going to get for the user set exactly to read, write. And we could also do a sudo chmod group equals read, other users equal read. And now it's set exactly to read for the group and for other users. And now I'm going to demonstrate what we get when we change permissions on directories. So I'm going to go ahead and clean up our demo items within this directory to actually run that with the right permission. And now we're clean. And create some new directories -p so that it creates directory tree. And now we have A with, and B within A, and then C within B. Now we're going to remove read from the all users group on A. Now we can't actually read what's within the directory if we don't have read to it, but we can still read the ACL on it. We can still move within the directory, but can't list what's within it. We can move into its subdirectory. So there we're okay, those are unaffected. All right, and now we're going to go ahead and remove execute permission on A. We can't read what's within A, of course. We can no longer read what is actually within B. And we can't read C. It's actually AB. So without execute, even though we still have it on that with D. So even though we technically still have execute permissions within B on C, if we remove it from a parent, we can't move to any of those directories within that structure. Just to demonstrate that. Here we've moved it for all users, and even though it's still present on B and C, we still can't move within those directories. So that's the impact of removing it from a parent, is that you won't be able to move within one of the subdirectories. In fact, actually, I'm just going to clean up here. And we're going to go ahead and move into demonstrating ownership. So and now our current owner, our current group is root. So with the chown command, we can go ahead and specify the user that we want to change ownership to and the file. And now my user has ownership of the file. And if we want to change the group, we can go ahead and start with a colon and then the name of the group and then the file. And I also don't need to use sudo for this because I am now the file's owner, so I can set the group. We point out though that to actually change ownership of the file, you actually need sudo access. So I couldn't find another user on the system and pass ownership of a file to them. I would need an administrator that has sudo to do that. All right, and so now this is the group on the file. And we can go ahead and set it back. And we can actually do a shortcut where we just put a colon after the user, and it will change both the user and the group. So now it's root root. And there's also another command to change group, which is chgroup. Also use that to change the group. Okay, now I'm going to demonstrate how we can change ownership recursively on files and folders. So before we do that, I'm just going to clean up here real quick. Back. The right things. And make our new structure. And I'm going to actually do this by UID and GID. I could do this with the name of the group and the name of the user. but we can also do it this way. And I just want to point out that we could also do this to change the permissions using the chmod command with the same flag, a -R. So let's go ahead and just list out what we have right now. And we're going to use a -R with the ls command to recursively list everything so that we can see that root is owner of everything. So we can use the ID command. And if we run it without any arguments, without, say, another username, just get our own ID. It lists out all the groups we're in along with their IDs and names, along with our primary group and its GID, and then our UID along with our username. So in order to do this, we can run a sudo -chown-r, and then we can use the group, or I'm sorry, the user and the group item. We're going to change it on. And now it's recursively changed it through the structure. If we had files in there, they would be changed as well. So I'm going to wrap it up here. We'll follow up with a video on special permissions. If you found this useful, please consider subscribing and liking the video. Also leave a comment and let me know what you'd like to see more of, and also any discussion about the topics we covered. Thanks for watching.